In this question, we're going to graph one cycle of the curve shown, and we're going to state the amplitude, period, phase shift, and axis of symmetry. Okay, well, the first thing we want to do is establish the values of A, K, D, and C. So we're going to factor 2 from the input of the function. Okay. Now looking at that, we can say that the amplitude is equal to 4. The period is going to be 2 pi over the absolute value of k. K is equal to 2. 2 pi over 2 is equal to pi. The phase shift is 3 pi over 4 radians to the right. And finally, the axis of symmetry is at y equals axis of symmetry is at y equals -3. Okay, so that's good information to have. Now we're going to go to our next slide and we're going to graph that. But before we do, we should make a note that even though it's not asked for, the key interval here is going to be the period divided by 4. So our key interval is going to be pi over 4. Okay, so going to the next slide here, we've got an amplitude of 4. We've got a axis of symmetry at y equals -3. We've got a phase shift of 3 pi over 4 units to the right, and we've got a period equal to pi. And it's important now to ask ourselves if we what our parent function is, and our parent function here is positive cos, and that's because the original question has a positive coefficient in front of the cos sign. Okay, so going back here, this is what we have. Now, since it's positive cos, what we want to do is ask ourselves, what does a positive cos parent function look like? And it looks like this. So it's important to know what those parent functions, what they each look like. Now that parent function has 5 key points. They all do. And the first point is going to have an x-coordinate of d. The second point is going to have an x-coordinate of d plus a key interval. The third point is going to have an x-coordinate of d plus 2 key intervals. The fourth point is going to have x-coordinate of d plus 3 key intervals. And finally, that last point will be d plus 4 key intervals, or in other words, d plus a period. Okay. Now, looking at this, we see that the first point is actually not on the axis of symmetry. It's one amplitude above the axis of symmetry. So the y-coordinate of that is going to be c plus an amplitude. The second point is actually on the axis of symmetry. Look at that, right on there. The third point is at the minimum. That's going to be the axis of symmetry minus an amplitude, c minus an amplitude. The fourth point's back on the axis of symmetry, and the fifth point is back where we started, one amplitude above the axis of symmetry. Okay, well, the d value is 3 pi over 4, and the c value is, and the c value, yeah, like I said at first, the c value is -3, and we're adding an amplitude to that. So -3 plus 4 is going to be 1. Now, the second point has an x-coordinate equal to 3 pi over 4, which is d, plus a key interval. Well, you'll recall from the last slide that the key interval is the period over 4, which is pi over 4. So looking at this d plus a key interval, we're going to have 3 pi over 4 plus pi over 4. So our x-coordinate will be 4 pi over 4. We're just going to call that pi. Our y-coordinate is going to be the c value. Well, the c value is the same as the y value of the axis of symmetry. It's -3. Now, d plus 2 key intervals, that's like saying 3 pi over 4 plus 2 of those pi over 4s. That gets us to 5 pi over 4. Okay, we'll do the last couple of x coordinates. We're adding pi over 4 each time, so 5 pi over 4 plus pi over 4 is 6 pi over 4. We'll call that 3 pi over 2. And finally, the last x coordinate is going to be 3 pi over 2 plus another pi over 4. So 6 pi over 4 plus pi over 4 is going to be 7 pi over 4. Okay. Now looking at our y coordinates, we see our c value is -3. Our amplitude is 4. C minus an amplitude is -3 minus 4, which is -7. Our fourth point will be back on the axis of symmetry, and our fifth point will be back up at the maximum. So what we're going to do now is, forgive my shaky hand, but we're going to do our best job of graphing this. Now I notice all my y coordinates are in the negatives. Not all of them, but they tend to be negative. So I'm going to, allow for that a little bit by drawing my x-axis way up near the top. It gives me more negative y coordinates space. My lowest common factor, or sorry, my greatest common factor of all my x coordinates is pi over 4. So I'm going to let the scale of this be pi over 4, because pi over 4 divides evenly into every one of my x values. And I'm going to let the scale on the y-axis be 1. Okay, so if I go to 3 pi over 4 comma 1, I'm right here. If I go to 4 pi over 4 comma -3, I get to here. 5 pi over 4 comma -7 is way down here. And then I get back up to 6 pi over 4 -3. In other words, 3 pi over 2 -3. And finally 7 pi over 4 comma 1. And it's hard to draw this on the tablet that I have, but I'll do my best. I'm not drawing something that's straight and rigid like this. That's not what I'm drawing. I'm trying to account for the fact that there's some curviness to it. So these functions are curvy, not rigidly straight. Whoops. And there we go. And that's our final answer. Now, as we all know, if we were asked to graph more than one cycle, that wouldn't be such a difficult task. We would just try to make sure that we draw our curve symmetrically in both directions and keep on going forever and ever. Okay, so it's important when we do word problem questions to remember that these periodic functions go infinitely in both directions.